I will admit I've been a bit obsessive with the design for the pellet feeder on the rocket mass heater. I've made a few burn grate prototypes in an effort to come up with a design that could feed pellets without the need for an electric auger and keep the grate clean from ash during the burn process. Basically make it maintenance free. In the last design, over time, the ash would stick to the grate and eventually clog it. The accumulation of ash would provide less space for the fresh pellets, and it would eventually choke out the system. You can see here where the remaining ash was left on the grate. If I made the spacing any wider, the pellets would just fall through. On my latest design, I stripped everything out and moved a few bricks around. I set in a new grate at a far steeper angle and then added the hopper next to the grate. Previously, the hopper sat on the grate, which made it difficult to remove for cleaning and modifications. Looking at the grate from top view, there is an outer frame which I call a sled. This frame has two sets of brackets that are used to space and support the individual grate slats. At the end of each alternating slat, there is a rake that comes out perpendicular from the slat. Over the grate there is a piece of expanded steel. Since the grate is so steep, this is used to contain the pellets and prevent them from flowing into the rest of the heater, but still allows the gases to flow through. Then above that is a cover which is used to direct airflow. As the pellets burn, they get smaller and eventually turn into ash. The weight of the pellets from the hopper keeps pushing the ash over the grate, essentially scrubbing the grate as they move over it. The rakes at the end of every other slat act as a resistance point, along as a support for the expanded steel, and the ash eventually gets pushed through the rakes and falls into the gap. Since the combustion air is flowing through this same gap, it helps to keep the ash from sticking to the steel. Normally, when the heater is first starting, there is an increased amount of pellets that aren't fully burned that will fall into the ash pan. Since the fresh air is flowing through this area, it helps to keep the pellets stoked and they eventually turn into ash. Here is my latest sled design. The brackets for the slats are pieces of angled steel that have slots cut into them and hold each slat in position. Inserting the slats is quick and requires little effort, maybe a few taps with a hammer for some of the corroded ones. One end of the expanded steel rests on the rakes, and the other is supported on the hopper. By making a few adjustments in the bends, you can have more or less pellets stored over the grate, which allows for the combustion amount to be tuned properly for the heater. Adding the parts to the heater is fairly simple. I just drop in the ash pan, then set the grate on the brick shelves, and then add the pellet hopper. To get the heater started, I usually dump a scoop of pellets first to help minimize the amount that will fall through the gap for the ash. Then I add the expanded steel screen and release the pellets from the hopper, holding the screen in place. I cheat a little and add a bit of gasoline to speed up the ignition. Once it's burning, I can then add the cover. It takes around 10 to 15 minutes for the system to get fully up to speed. Looking inside, the combustion chamber is burning hot enough whereas the steel cover glows red. The flame inside the tunnel has a smooth, laminar flow, unlike most heaters I've seen. I've had experiments with a few different tunnels, and I'm finding I'm getting hotter and more efficient burn with the laminar flow. I'm sure that will generate a few comments. When I remove the cover, it completely disturbs the airflow through the system, but you can see how the pellets are gasifying. The pellets now feed smoothly into the burn chamber. This video is displayed at normal speed. With this design, I doubled my burn rate, and the heater now consumes 12 pounds per hour. Inside the ash pit, there are a few unburned pellets that have fallen through, but they don't last very long. A few of my slats are 304 stainless steel. This is a comparison between a standard piece of steel after around 20 hours and the stainless with around 200 hours. The stainless brushes right off and looks like new. The expanded steel is gone after around 6 hours. Obviously, I'm going to need to make a small investment in some stainless parts, including a new chimney liner. Taking a quick look at some of the temperatures on a day that's equivalent to the previous readings. The air temperature has gone from 54 to 70 degrees. Over the first radiator, it's gone from 226 to 352. Before the second radiator, from 189 to 297, and the temperature entering the ground went from 96 to 164. The water temperature has gone to 146, which is an increase of 64 degrees, or running a 34,000 BTU water heater. The fish are really loving it now. That's about it for now. I'm hoping the heater will last through the winter, and in the spring I'll tear it apart and do a video on all the parts that have failed. Thanks for watching.